Hi, hello. In this video, I am going to explain you about graphs of functions which are very useful in calculus. And mostly it is very important to JEE aspirants. Okay, friends, let us see in that first graph, modulus function. Of course, all of you know about f of x is equal to mod x. This is modulus function. It is defined as modulus of x will come out as x if x greater than 0. Mod x will come out as minus x if x less than 0. Mod x is equal to 0 if x is equal to 0. Okay? Of course, whenever input is positive, it will come out as x. Input is a negative, it will come out as minus x. If input is 0, output is also 0. Its graph will be V-shaped. Whichever the positive values you take, suppose x value 1 we are taking, corresponding f of x. F of x means it is y value. Corresponding y value will also be 1. Suppose x value 2 we take, modulus 2 will come out as 2 only, corresponding y value is 2. Suppose if we take x value is 3, corresponding y value is also 3. Suppose if I take x value is minus 1, corresponding y value, modulus of minus 1 will come out as plus 1 only, because whenever input is negative, it will come out as minus x. So its outcome is minus x. Suppose x is minus 1, modulus of minus 1 will be equal to minus of minus 1. Modulus of minus 1 goes to second case. In the second case, mod x defined as minus of whichever the value lies inside. So minus of minus 1 is plus 1. So minus 1 outcome is also 1. Minus 2 outcome is also 2. Minus 3 outcome is also 3. So that's why modulus x graph will be V-shaped. And of course, you see, left to right x values are increasing on x-axis. Corresponding y values are decreasing till 0. After 0, after this stage onwards again, as x is increasing, corresponding y values are also increasing. Okay? So that's why this is the graph defined for all real values on x-axis. Domain is equal to R. And to find the range of a graph, we have to observe the boundaries of a graph. Lower boundary of the graph is x-axis itself. Upper boundary does not exist. That's why range of a graph is, this is y is equal to 0 to somewhere y is equal to infinity. Of course, infinity is not a real number. So that's why its range is closed interval 0 to infinity. So the minimum value of the graph is 0, means lower boundary. Maximum value of the graph does not exist. And also you see, if you draw a line parallel to x-axis which intersect the graph in more than one point, then it is not 1, 1. So if I draw a graph parallel to x-axis, it is intersecting the graph in two different points. So that's why mod x graph is not 1, 1 function. We can also decide 1, 1 nature through the graph. And observe that mod x is continuous function on its domain R. How to check whether function is continuous or not? If we can draw the graph of a function without lifting marker from the board or without lifting pen from the paper, then it is called a continuous function. Of course, we can draw its graph without lifting marker from the board. That's why it is continuous everywhere. And differentiability nature. Whenever graph has sharp curve, at that particular point function is not differentiable. Otherwise, it is differentiable everywhere. Observe that from left side, graph is decreasing till 0 it is decreasing. Immediately at 0 it is taking turn. So there is a turning point at 0. Of course, it is a sharp edge. So that's why it is not differentiable at 0. means it is differentiable everywhere other than 0. That can be written as mod x is differentiable on r minus singletons 0. Okay? Mod x is not a periodic function. A function is periodic only when its graph will be repeated after certain interval or after certain stage. So there is no such situation here. That's why it is not a periodic function. Of course, as x values are increasing from left to right, corresponding y values are coming down. As x values are increasing, corresponding y values are decreasing. Both are in opposite direction. It is called decreasing function. So minus infinity to 0, it is a completely decreasing function. After this stage onwards, as x values are increasing on x-axis from left to right, corresponding y values are also increasing. That's why it is called an increasing function from 0 to infinity. So this is about modulus graph, and most of you are getting doubt here, I think. As you know, modulus x always positive, but I am writing here minus x. Don't confuse that. Suppose modulus of 2020, according to our definition, it goes to first case. Modulus of 2020 is looking like modulus x. Instead of x, I considered here 2020. 2020 is positive real number, that's why it goes to first case. In first case, mod x will come out as x. Whichever the x lies inside the modulus bracket, as it is will come out. But modulus of minus 2020, it is also looking like mod x, but this time in place of x we have minus 2020. Of course, minus 2020 means it is negative real number. It goes to second case. Second case definition is mod x, whichever the x will come out as minus of that inside quantity. So here inside quantity is modulus minus 2020. So it's according to its definition, its value will be minus of minus 2020 is nothing but 2020. Okay, this is about modulus x graph. See friends, our next function, greatest integer function, GIF, or step function. Okay, you see, a function f of x defined as step of x. The square bracket represents step. Read as step x, and most of the people will feel difficult while defining a step function, but I would like to explain you in simple method. That is, step x is equal to x as it is if x is an integer. Step x is equal to immediate left integer of x if x does not belongs to z. Suppose whichever the integer we have considered in step bracket will come out as it is. If it is other than integer, on the real line its immediate left integer we have to consider. That is the definition of step x. For example, step of 5, it goes to first case or second case. 5 is an integer, that's why it goes to first case. So in first case, step x is equal to x as it is, step 5 is equal to 5. Step of 5.3, instead of x we have 5.3. 5.3 is not an integer, that's why it goes to second case. Second case says that its immediate left integer is its answer. Its immediate left integer is its answer on the real line. Real line minus infinity to plus infinity. Somewhere here 4, 5, 6, 7, 5.3 lies between 5 and 6. Okay. Whenever x is not an integer, it is a real number, its answer is its immediate left integer. 5.3 to left side there are infinitely many integers, but among all those which is its immediate left integer, that is 5. 5 is its answer. So step of 5.3 will come out as 5. Similarly, minus 23, of course it is an integer, its answer is minus 23. Minus 6.7 is not an integer, its immediate left integer is minus 7 on real line. Okay, and minus 2020 is minus 2020, minus 0.3 is minus 1. So these are the examples. Now let us draw the graph of f of x can also be written as y. See, suppose x value is 0, step of 0 is 0. That's why x0 corresponding y is also 0. X value 0.1, step of 0.1 will be 0. Step of 0.2 is also 0. Step of 0.3, 0. Step of 0.4, 0. Step of 0.9, 0. So the graph is till left side of 1 on x-axis. Okay, at 1, step 1 is immediately goes to 1. Step 1.1 is 1. Step 1.2 is 1. Step 1.3 is 1. Till step 1.99 something, left side of 2, graph is this. At 2 it is immediately goes to up. Till left side of 3, this is the graph. At 3 again it is 3. Till left side of 4, it is the graph. At 4 again it is 4. Till left side of 5, this is the graph. In the same way, step minus 0.1 is minus 1. Minus 0.2 is minus 1. So, till minus 1, this is the graph. Next, at minus 1 also minus 1, but at minus 1.1 it is minus 2. So this is the graph. Okay. At minus 2.1 it becomes 3. This is the graph. At minus 3.1 it becomes 4. This is the graph. Observe that at minus 4.1 it is 5. This is the graph. Observe that graph is looking like steps. Graph is looking like steps. That's why it is also called a step function. Now the properties of this step function. See, for what values of x it is defined for each and every real value of x on x-axis. For 1.1 there is a graph. For 1.9 there is a graph. For 2 also there is a graph. For 0 also there is a graph. That's why for the values of x, whichever the values of x for which the function is defined is called domain. Domain is whole set of real numbers. But range is what about the corresponding y values? Here 0 only. Here 1 only. Here 2 only, here 3, 4, minus 1, minus 2, minus 3, minus 4, and so on. That's why range is only z. Okay? What about the minimum value? Minimum value, range is z means minimum integer is a minimum value. Minimum value does not exist. What about the maximum value? Maximum value also does not exist. Okay. Now you see, it's 1-1 nature. Check whether the function is 1-1 or not. We can check the function by the line parallel to x-axis. It's 1-1 nature. If the line parallel to x-axis intersect the graph in more than one point, it is not 1-1. So we can draw a straight line which is parallel to x-axis and intersecting the graph in many points. So that's why step x is not one function. Of course, what about its continuity nature? We can draw the graph of a function 0 to left side of 1 continuously. At 1 we have to lift the marker from the board. Means here to here we need to lift the marker. That is discontinuity nature. Till here it is continuous, again it is lifting. Till here it is continuous, again it is jumping. Till here it is continuous, again it is jumping. So that's why step x is continuous. Step x is continuous on all the set of real numbers except integers. At integer points it is taking jump. Okay. Next. Again what we are checking? Step x differentiability nature. Wherever the function is discontinuous at those points it is not differentiable. So that's why step x is also differentiable. See, differentiable nature types or function is discontinuous at those points it is not differentiable. Function is having sharp edges, there also it is not differentiable. So that's why here function is discontinuous at integer points. Those integer points are non-differentiable points. And also, is it periodic? What is the period of this function? So here to here graph is y is equal to 0. Here to here graph shape is the same, but not y is equal to 0, it is y is equal to 1. It's not the same as y is equal to 0. Here it is y is equal to 2, y is equal to 3, y is equal to 4, y is equal to minus 1. So graph is not repeated anywhere after certain stage. That's why step x is not a periodic function. Observe that graph of step x is looking like steps. Graph of greatest integer function looking like steps. That's why it is called step function, because it is defined for all real numbers. Its domain is or, its range is z. Minimum maximum values does not exist. And is it increasing or decreasing nature? As x values are increasing, y values are constant. Because here x values are increasing from 1 to 1.1, 1.1 to 1.2, 1.2 to 1.3, but y value remains unchanged. It is throughout this interval y is equal to 1 only. So that's why it is a neither increasing nor decreasing function. So this is about step x function and its properties and its graph also. So friends, please subscribe my YouTube channel Maths Tree by TS, and if you like this video, please subscribe and share and leave a comment in comment box. Okay? Thank you.